Happy snow day, everybody. Let's do some homework, shall we? I got one other set of questions that also came up about the practice quizzes, so I'll show you some of those on Excel here as well. So I'll start with the homework. Allow me to do a little screen sharing and switching here from time to time. Hope everybody's enjoying their snow day. All right, so that's our homework assignment. A whopping 22 questions. But make sure you take a look ahead because in the future there will be more than 22 questions on every occasion. Anyway, PPP Plumbing completed 30 jobs last month with a mean revenue of $5,430 per job. The president wants to know the total revenue for last month. Based on the limited information, compute the total revenue. So there's not a whole lot we have to do to compute for this. We do know, we don't know the shape of the distribution if the jobs were normally distributed, but we don't need to know that. The two things that we can identify here is that there were a total of 30 jobs and $5,430 per job, which I would solve the problem by $5,430 for 30 jobs. Multiplying those two things together tells me the total amount of money I would have made. Some of those jobs would be more than $5,430. Some will be less, but on average, $5,430 times 30 jobs means about $163,000, $162,900. That's the total there. And rather than constantly switch the screen sharing, I'll read the question, and if you've got the assignment at home, you can also complete it. That means I don't have to switch back and forth from Excel windows and back to Chrome, etc. So question one would be $162,900, C. Number two, a specialty bookstore concentrating on used books sold via the internet. They're $1 each, hardcover or $3.50. 50 books sold last Tuesday morning, 40 were paperback, and the rest were hardcover. What's the weighted mean price of each book? So basically, there were two types of books sold: paperbacks and hardcover. Paperbacks were $1. Hardcover were $3.50. The frequency or number of books of each type sold. There were 50 total. 40 were paperback, and the rest were hardcover. So 50 total minus 40 paperback means that there are 10 hardcover. 40 and 10. Our question is, what's the weighted mean price of a book? So we don't sell a whole lot of hardcover, but we do sell some. And they are sold at a premium. One thing that would be useful to us to know would be to know what proportion of each type of book there is sold. I'm going to start Control T, turn this. I don't want this in the table. Okay. Now this is a table. I want to be able to get the relative frequency of each type. I'll start by calculating the sum, all equals auto sums, and then say the relative frequency of each type of book. Looks like it's 80% paperback and 20% hardcover. In order to apply the mean equals x times p of x formula, we have to get that column for x times p of x, where we take $1 times the probability. And then Excel will do that for both of these columns, in both cases, or both of these rows. So we'll take 350 automatically times 20%, or x times p of x. Control Shift 4 will turn it into money, please. and that's $1.50. So the weighted mean, number 2, the weighted mean price of a book is $1.50. Shift F11 will get me a new sheet so I don't run into that table problem again. Hey, number 3. Looks like we're on to concept questions. There may not be math questions in here, but number 3. Number 3. Total of 10 observations in number 3. 10 observations. No two values are the same. Therefore, there is no mode. No mode when no values are the same. What's the answer number 3? Number 4, Shift F11. Let's get a new sheet. Number 4 says that there's a total of 4 observations. 1, 1, 2, 2. Looks like it's 1, 2, 3, 3, and 4, 4. Zoom out just a little bit. So we have observation and value. Where observation is, this is the first observation. Oh, silly. The first observation is a value of 1. The second observation is a value of 2. The third observation is a value of 3. The fourth observation is a value of 3. The fifth observation is a value of 4. And the sixth observation has a value of 4. That's a problem. Question now is, what does this look like in terms of a histogram, in terms of its mode? So to turn this into a histogram, I'm going to follow my keystrokes. Alt-NV turns this into a pivot table. I want to be able to count each value. And I want some. I mean, I want some, but can't have any. I don't want some. I want count. This is a frequency table for these particular x values. That's effectively what we did there, is that x can take on a number of different values, 1, 2, or 3, 1, 2, or 3, or 4. And then it occurs with a certain frequency. That frequency is relayed here. This is what it looks like as a histogram. I need to save it. This is what it looks like as a histogram. Again, across the horizontal axis, we've got 1, 2, 3, 4. 1, 2, 3, 4. There's one instance of 1, one instance of 2, 2 instances. And that's what we're talking about over on the left-hand side. There are 2 instances of 3 and 2 instances of 4. So visually, we have one hump. It goes uphill to 3 and 4, and we've got a negatively skewed distribution here that generates one maxima. Question has no mode, has one mode, has 2 modes that create 2 maxima, or has 2 modes that create 1 maximum in a histogram? The answer is D. Creates 1 maximum, and that's this hill at the top of 3 and 4. I wouldn't look at this distribution and say it's bimodal, because 3 and 4, the 2 values which occur most frequently, they're right next to each other. So it's not like it creates 2 separate hills, 3 and 4 right next to each other, and they're both at the same height. Back to question 5. Using the cellular plan data. That cellular plan data is here. Let me make sure that's what's being. Get to the cellular plan data. That's still me. Cellular plan data. Determine the median tier. So Control T, turn this into a table. Let's see if I can put these in some sort of order. Well, alphabetically doesn't actually put them in the tier that I want. Bronze is actually the lowest, followed by silver and then gold. So the order that they're in right now isn't the order I need them in. It doesn't look like there's anything here that's going to help me sort these out. But if I were to put them in order some other way, let's just get cheeky here. We're going to create a new variable using I think the right way to do this would be to use a lookup table. So I'll do it the right way. I'm going to make a quick table where it says bronze, silver, gold. Bronze is the smallest, silver is the next, and gold is the best. So 3 is the highest, and bronze is the smallest. Now this, I'm going to give a name to this table. I'm going to call it table_metals. When I generate tables, I call them table_whatever in the name box because I don't know, it's just good because I want to have a bunch of names of stuff. If it's a bunch of row headers, I want it to say header underscore. If it's a bunch of column headers, I want it to say column underscore. It's just a table that I'm going to use to look some things up. And here's how I use the lookup table. I want to be able to give myself assign these bronze a 1, gold a 3, and silver a 2 because bronze is the lowest. I use the Vlookup function. It's going to look up. There's 4 arguments in here. The first thing I want to do is look up the value that's in column D, which tells me which value for the tier it is. Then I use a comma to separate the first argument from the second argument. The second argument is where do you want to look this thing up? So I want to look up whatever that value is for tier. I want to look it up in that table I just created. And now it's going to look at that table and say, hey, if I see the word bronze, I want you to put a 1. If I see the word silver, I want you to put a 2. If I see the word gold, I want you to put a 3. It will know which value to return because the second column in that table, was a 1, 2, or a 3. The 0 is the fourth argument. It says I want an exact match usage. That is, if I see anything besides what's actually in this table, I want you to return an error because the only thing I want it to return is exactly bronze 1, silver 2, gold 3. And now I have this column where bronzes are 1s, golds are 3s, and silvers are 2. So I can call this column tier rank, sort it smallest to largest, and now right here, once they're sorted from smallest to largest, I can see that silver separates the lower tier from the higher tier. Therefore, silver is our median tier. About half of the observations or half of the respondents are below silver and half are above silver. Now I'm going to do a quick correspondence check. Let's see. And I think we're still good. I will have somebody sent me a copy of their practice quiz, and it looks pretty good. So when we get done doing the homework here, I'm going to pull that up and share with anybody because all those practice quizzes effectively do the same thing. But okay, cool. Number 6, using the cellular plan data, determine the modal tier. Well, we can determine the modal tier using that pivot table that we just created. Did we create? No, we didn't create a pivot table for this one yet. We created a pivot table for the other one. So tier. Let's get a count. The modal tier would be either bronze or gold. In this case, This is not ordered data. You couldn't turn this into a histogram. You could turn it into a pie chart or a bar chart, but you couldn't turn this into a histogram. In this case, you don't end up with the situation like we had before with 1, 2, 3, 4, and you have 3 and 4 next to each other, both with the highest frequency. There's no specific order. Well, you know what? There is a specific order here. You do put these in order. So I probably would say, yeah, you know what? I can put bronze, gold, and silver in an order. Like that, like I did with the 1s, 2s, and 3s. So yeah, while I can't necessarily put 1, 2, 3, and 4 like ratio level metrics, I certainly can put these things in order. Wearing the Cleveland Browns hat. Not wearing the Cleveland Browns hat, actually, I was before. I can put these things in order, bronze, silver, and gold, and I end up with bronze and gold, D as the modal tier. 7, using the cellular plan data, determine the median plan. Well, if I look at the different plans, those plans, I can't seem to put in any particular order. I could only determine a median if I could put these in order. And I don't know which is the most and which is the least in terms of, well, what? I mean, is it the most amount of data? Is it the most amount of minutes? Is it the most amount, highest cost? There's a number of different ways that I could try to sort these, but it's not clearly defined as far as this variable is concerned. Not as clearly defined as, let's say, $10 is more than $5. So clearly defined, I could say $10 is twice as much as $5. But I can't tell you that Framley is half as good as the all data, no minutes plan, or that the unlimited talk and text is any better than the baller plan. Since I can't put them in any particular order like that, the answer to median plan has no median. Number 8, we're also going to look for the modal plan. So as long as we can get a count, which we certainly can, as long as we can get a count of these, it looks like Framley and unlimited talk and text both have a frequency of 3. So Framley and unlimited, answer D. Number 8 is D. Number 9, using the cellular plan data, determine the mean total bill. So I'm just going to swap out total bill here into values. And I say that the sum of total bill is 1,030, presumably dollars. But the average, if I change this to average, shifts the decimal point over by 1 because there's 10. Determine the mean total bill should be $103.40. Number 9, E. Number 10, using the cellular plan data, what is the standard deviation of minutes? So I'm still just going to work here. Say minutes used, drag that down here. The sum of minutes used, well, no minutes is no longer dollars. That says sum of minutes used. Treating this as sample data, we see that the standard deviation is somewhere around 286. Number 10 is B, bravo. Number 11, one extremely high score will drastically affect the median. Always, sometimes, or never. In this case, 11 is never. An extremely high score will not affect the median. If I were to have 5 numbers, 1, 2, 3, 4, 5, right here, this is the median. Three is the median. Now 5 could be 500 and 3 is still the median. 5 could be 5,000, 1,000. 3 is still the median. So the answer to number 11, extremely high score never affects the median. Number 12, the sum of the deviations from the mean for a set of data will equal 0. Well, let's use this 1, 2, 3, 4, 5 data set as an example again. I'm going to give it a name. I'm going to call it data or data, depending on where you're from or how you feel this day. Turn this into a table. Hey, it's a one-column table. Why not? The mean of this is going to be 3. Come on. Fine. So I take the average of this, and the mean is 3. Now I can change these numbers to be whatever I want them to be. And it doesn't matter, because I don't want you bold anymore. And I don't want this one to be bold down here. That number will always stay the same. It will get a little erroneous if I separate that out, but all right. Now we want to know the deviation from the mean. All that means is say, how far away is that particular observation from the mean? So 1 minus the average is 667,492, because the average is 667,493. Question, the sum of the deviations from the mean will always equal 0. Well, let's find out what the sum of these deviations from the mean is. Given the fact that I was just mashing my fingers in the data column, and we still ended up with the sum of the deviations from the mean to equal 0, indicates to me that it's probably going to always be true. And not only is that a pretty good indication, it is an identity. Yeah, it's always true. That's what the mean does. That's how we define the mean, is it's the value that everything else has a sum of the deviation equals 0. 13, for any distribution, there are an equal number of values above and below the median. That's true. That's the median's definition. 14, for any distribution, there are an equal number of values above and below the mode. That's false. That's definitely false, because the mode is simply the most popular value. And if we looked at something, it doesn't even really matter. It could still be this data. Well, in this case, we have 2 modes. And there are not an equal number of values above and below bronze, because there's nothing below bronze. Bronze is the lowest, but there are things above it. So question 14, there's an equal number of values above and below the mode, is sometimes. It's not never. It's not always. We found one time when it didn't happen, so it can't be always. But we know that there's at least one time when it always happens, and that's in a normal distribution. Because in a normal distribution, the mean and median are the same. Therefore, same things that apply to the median apply to the mode. And for the median, there's an equal number of values above and below it. 15, for any distribution, there are an equal number of values above and below the mean. Same thing applies here. No, there are not. There are not. In this case, whatever this random button mashing data set is, there's only one value here, which is above the mean. Everything else is below. I was joking. That's below the mean too. Sorry, above the mean. These 3 right here, 1, 2, 3, 1, 2, 3, 3, 4, 5, or this one, and 1, 2, 3, 2, 1. All those 3 are below the mean. Those 2 are above the mean. There's not an equal number of values above and below the mean. So that's one example where it's not true. But in a normal distribution, the mean and the median are the same. Therefore, the same things that apply to the median apply to the mean. And the median says it's the value above and below which the same number of values occur in your data set. So 15 is sometimes. 16, the standard deviations for test scores in Class A is 10 and Class B is 20. Which one is more consistent? The one with the lower variation is more consistent. Class A has a deviation of 10. Class B has a deviation of 20. So 10 is more consistent. Me again. Where are we here? A is more consistent because it's got a smaller standard deviation. It's got less variation. 17. The means for the test scores in Class A is 90 and Class B is 80. Class A is not more consistent necessarily. Class B is not necessarily more consistent. C is the correct answer. You cannot determine consistency from the data given explicitly. If I had to guess, however, assuming that these two things have roughly the same shape, I would probably conclude A is more consistent, simply because you hit a cap generally around 100. So if the average is 90, there's going to be a bunch of values squished together towards the top of the distribution, and you get a very steep, negatively skewed distribution. Will tend to be a little less dispersed. But simply looking at the means can't determine the consistency precisely. The mean, median, and mode in any symmetric distribution. Well, necessarily, if it's symmetric, the mean and the median have to be the same. You can have a bimodal distribution. In other words, one mode on one side and one mode on the other side of the mean. But the mean and the median are equal in a symmetric distribution. You can have a modal distribution with one mode, so it looks like the normal distribution, or you can have a bimodal distribution. 19 through 22, we should all be pretty good at. Population mean is mu, the sample mean is x bar, the population standard deviation is little sigma, and the sample standard deviation is s. Submit for grading. So that's 1 through 22. Those are real quick. There's not much to it. I think we probably accomplished that in like half an hour. That wasn't a whole lot to do. I'm now going to take a look at one of these quizzes somebody sent me. People ask for answers to quizzes, and I say the same thing all the time, is that I don't want you to practice for the quiz. I want you to work it out and try to figure it out, work with other people. That's how you're going to actually commit this stuff to memory. I'm always concerned when people just do a quiz and they see the answers on the quiz and it makes sense to them. So then they think, oh, I must understand the material because the answers that I see here make sense to me. So this quiz already does pose one problem to me. There's no name on it. And because there's no name on this quiz, I don't know who to award the points to. That's okay. I'll remind you that tomorrow when you take your quiz to make sure to do that. This looks pretty good. So the first question is generate a relative frequency table, and that's filled out on the left side of the quiz over here. The x values are the things that go along the x-axis. In this case, there are 5 x values, 0, 1, 2, 3, and 4. This histogram is actually based on the data that's floating around in the first 3 modules. That is the Applewood auto group data. So if you were looking around for data to poke with and practice making pivot tables with, then you may have made this pivot table yourself. And I'll bring it up here in a second and actually show you. But for now, we'll just take a look at this quiz. And we'll see the relative frequency table here is on the left, and that looks pretty good. The probability that a car selected at random had 3 previous owners would be the relative frequency associated with the number 3. 3 has a total of 10 observations. And if you add up 61, 75, 29, 10, and 5, I believe that you get 180. Yeah, 180. Very good. So n's the sample size, x bar is the sample mean. Good use of symbols. I mean, I don't normally look at that. I'm just taking the time to look at it right now. Um, I don't normally look at that because I just look at what you put in the answer part here. Well, part of that answer is this relative frequency distribution up here. I'm going to pull up the actual data that I use to generate that and do all my work because I don't want to do work by hand. The answer's down here. The number of previous owners, 1A, that's correct. That's the x-axis, number of previous owners. Says so right here. So whatever's written down here is the x-axis label. 1B, the probability of a car selected at random had 3 previous owners is the probability of X. So the probability of a car having had 3 previous owners. So if 5% is the right value in this table, and I haven't done the math yet, so I don't know, then that would be the appropriate thing. Total number of cars sold, N, is 180. That's good. The average number of previous owners is not 0 plus 1 plus 2 plus 3 plus 4 divided by 5, which is 2. It is not 0 plus 1 plus 2 plus 3 plus 4 divided by 5, which is 2. That's not what it is. The average number of previous owners is where you have to find out either the total number of previous owners and divide by 180, because that's the number of cars. So how many people? Well, there were 61 cars that no people owned. There were 71 cars that had 1 previous owner. There were 29 cars that had 2 previous owners, so that's 58 previous owners. 10 cars had 3 previous owners, so 30 people touched those cars. And then there were 5 cars which had 4 previous owners. 20 people touched those cars. We find out the total number of people and divide by 180. That's going to give us the value here. And 1 looks pretty reasonable. There's no instructions on here about rounding. I've gotten better as I've gotten older at specifying exactly the number of decimal places I want you to round to. So I'll be able to give you that information as well on the actual quiz. This quiz was from 2 or 3 semesters ago. So it may have been, I've hopefully improved on those things. C2C, the median number of previous owners. The median number of previous owners here is 1 as well. So there were 180 total cars. And there is, if we line those 180 individuals up, there's going to be a number in the middle and say, all right, you 90 people have the cars with the fewest number of owners, and then this other group of 90 people are going to have the cars with the most previous owners. That second group of people, the cars with most previous owners, if we look at this histogram, let's start at the right. We know that there are 5 cars who have 4 previous owners. Those 5 people, those 5 cars, you name it, those 5 are on the high end because they have the, let's call them the oldest cars, but they're the cars with the most number of previous owners. Followed by the 10 people who have cars which had 3 previous owners. So right now we've got 10 plus 5 or 15 cars, the 15 oldest cars. You know what? Let's throw in the 29 people who had cars that had 2 previous owners. At this point, we have 29 plus 15, which is 44. Those are the 44 oldest cars. The 44 oldest cars are on top. But then we've got the 61 newest cars, 61 being the number of cars that had 0 previous owners. We have 61 cars on one side, 45 on the other, and they sort of cancel each other out. Sure, there's 61 new cars and only 44 call them oldest cars. But the balance in the middle there is one previous owner. So the median number of previous owners is actually 1 rather than 2. The mode is 1. 75 is the most frequently occurring example here. So just to take another look here in Excel, let's see, do I have the Applewood data? Give me 2 seconds and I'll pull up the Applewood data. This is the data that's available in Module 3. I was joking. No, I was totally right. It's in module 3. So this is uh, all 180 cars uh, horizontally. It's the 180 cars from the that histogram that we're looking at. Now, this is 180 cars sorted by price, and those some of those were newer cars and some of those are older cars. This doesn't directly tell us a story about that histogram we're looking at, but this is what I mean if you were to sort cars from the lowest to the highest. For example, these cars in the red over here, the cheapest car, the car that we made the least amount of profit on, 294, 323, 335. Each one of these numbers represents a particular profit. We go all the way to the high end of the scale. We say some cars we sold, we made $3,000 on. That's a lot of money. But somewhere in the middle, there's going to be a median, and that's the value here in yellow. The analog to the problem we're looking at is that there's going to be on the left-hand side of these cars, there's going to be 61 cars, the 61 newest cars, 61 cars that have 0 owners. We could look at those and think about them as being analogous to the ones, actually, if they're newer cars, they're probably on the right. They're probably these green ones. But regardless, there's 61 cars on one side of this lineup. And there's, on the other side of the lineup, the 5 oldest, and then the 10 after that. If I just use this data here, create a pivot table, number of previous owners. So this is exactly what we were looking at before. This is a histogram based on this pivot table here. So the old workbooks don't allow you to double click on the header, which is dumb. So these are the relative frequencies. Oh. These are the relative frequencies, which should be the answers in the X and P. Really? Oh, you won't even let me do that. All right. So old Excel workbooks. Now I'm hoisted by my own petard, apparently. Fine. So either as percents or as decimals, these are the values that I will be looking for or would be looking for in the example quiz we just had. Some of those numbers look the same. Some of them, I think they're all the same. 34, 42, 16. I got 6 and 3. I think that quiz said 5 and 3. I'll probably cut you some slack. We just got to make sure we round appropriately. Yeah, 0.056 rounds to 6%. And that's, I believe, 10 out of 180, or 1 divided by 18. I don't need all those. Thanks. So I would, based on that quiz that we were looking at before, the only question that person, oh, we didn't even do the average yet. The average number of previous owners. I don't want you looking like that. These numbers look pretty familiar. I need to update this workbook. Yeah, that's rounded to 2 decimal places. 1.02 is the value that was on that quiz. So everything about that quiz, I would I prefer that answer be rounded to 6% rather than 5%. And the median is incorrect. The median is not 2. Uh, home. The median is not 2. The median is 1. I know. I could turn this particular set of data here into a 100% sum stacked bar chart. Which it's been a while, but we'll see. Yeah, 100% stacked bar chart. Here you go. So this big blue down here, this big blue chunk down here represents those 61 cars, the 61 cars who had 0 previous owners. That's the blue bar down here. Because there's a total of 180 cars, the total 180 cars, the car that is half of that, or the 90th or 91st car, wherever this line would be right here. Oh, let's change this. All right. So 90. Now, wherever 90 cuts through these 180 cars would represent the median, because these blue ones on the bottom have 0 previous owners. These tiny blue ones on top have 4 previous owners. The purple ones had 3 previous. The green had 2 previous. So this 180 represents the 180 cars in the data set. And right here in red is the 75 cars that had 1 previous owner. You go above this 90, and we have the, we'll call them oldest, but they're not oldest. They just have the most previous owners. Most well-used, well-owned cars are the ones above the 90. Below the 90 are the newest ones. So that's what you can expect for your quiz tomorrow. Let me do one last correspondence check before I'm out. Yes, I know I was late getting us launched today. I apologize. The yeah, the internet roads were a little icy, aka troubling between parking lot blades. So yeah, that's cool. That's the update. I'm not sure I'm going to be able to get back to any more questions. If y'all email me tonight, you can take a crack at it if you want. But otherwise, we'll do these quizzes tomorrow morning. If there's not clearing of snow and there's any sort of delay or cancellation, we'll play it by ear. But we'll get done what we need to get done. And outside of that, hope everybody enjoyed their snow day. And I'll see you tomorrow.